Awk can do a lot more than just match patterns and print fields. Awk is a full-fledged programming language in its own right. It has variables, if statements, while loops, and more. We could spend a lot of time trying to master the details of the Awk language, but today we're going to focus on just one of the more advanced features of Awk, associative arrays. An array is a variable that can hold more than one value. It does this through subscripts. You can write the name of the variable and then include brackets with a reference to the particular item. The primary advantage over using individual variable names is that arrays can easily be processed by a loop, as we will soon see. Most arrays use a number as the subscript index, but Awk uses associative arrays, which means that we can use any value we like as the index to our array. This comes in handy in a lot of ways, but we'll be using it to create reports that include totals. As usual, the best way to make sense of all this is to see it in action. I'm going to write a script that will count the number of times each login shell is assigned to a user in the /etc/password file. Before we get started, let's review the structure of the file. Each line of the password file has 7 fields that are separated by a colon. The fields are the username, an X that indicates that the password is stored in a different file, the user ID, the group ID, any additional information about the user such as their full name, the user's home directory, and the shell that will be executed when the user logs in. Our goal is to count the number of times each shell, or other command, it doesn't have to be a shell, is used in the file, so we are focusing on the 7th field. What makes this task interesting is that we don't necessarily know what shells are present in the file when we begin. New users might have a different login shell than any currently being used, so we don't want to restrict our script to only counting the shells we see. That method would also be prone to error since we could easily miss one of the currently used shells. Awk is perfect for this task. Let's start writing our script. The first thing I'll do in my awk script is add a begin statement that sets the field separator to be a colon. Next, I need to add a line that will count all of the different shells. But before I do that, I'm going to save this so that I can turn on my syntax highlighting. I want my script to look at every line, so I'll leave off the pattern and just use the open and close braces. Inside of those braces, I'll use an associative array to count up the number of times each shell occurs. Just like any other variable, I can give it any name I want. I'll call it user shells, but I'll also use the square brackets and a subscript that refers to the 7th field. This will group all occurrences of a particular shell together. When I see a particular shell, I'll add 1 to the variable in that location. This line is the key to our script working, so let's go over it one more time. I have an array variable named user shells. I can tell it's an array because it uses this subscript notation with these square brackets. The first time I see any given shell, such as /bin/bash, which is going to be referred to by the $7, I'll add 1 to the variable user shells in the location specified by /bin/bash. The default value of a variable in awk is 0, so this means that the first time I see a particular shell, I'll have a 1 in that location. The next time I see the /bin/bash shell, the subscript will refer to the same location, and so it will add 1 to that same subscripted location, and so I'm going to be counting the number of occurrences of that particular shell. Because I haven't specified a pattern, this command is going to run on every line in my file. Now we want to print the totals after we've looked through the whole file. We can do that by using the end pattern. The statement for this portion is going to be a for loop. For loops are often used with arrays to process each of the items they contain. We'll write this loop as for, open parentheses, shell in user underscore shells. Then print shell, comma, user underscore shells, shell. So what this is doing in this for loop, it's a little bit of a different structure than what we used in bash for loops, but it's saying for each subscript that occurs in user shells, I'm going to assign that subscript to a variable called shell. And then I'm going to print the subscript that occurred and also the number that it contains at that location. Since I have a single statement in my for loop, I don't have to use any braces or other notation to identify the beginning and end of the loop. If I had multiple statements in the loop, I could use curly braces to mark the beginning and end of the loop. Now I am going to close the braces for my end statement. Save this. And then run my script and see what happens. The script prints out each shell it found in the file and the total number of times it saw that shell. The one standing by itself at the top of the report is there because there's one line in my file that has no shell listed. The rest of it should be easy to understand. Bash occurs twice, sh occurs once, and false and no login occur frequently in the file. These are shells used for services that are never intended to log in with an interactive session. In summary, associative arrays make it possible for us to use awk to form totals about unknown data. They are often processed with a for loop at the end to report the data. This is a very powerful feature of the awk language. I hope you find it comes in handy.